Greetings, science fam. Today we're going to be looking at mass. Doesn't sound too exciting in that, but it's actually really important because mass is going to eventually allow us to measure how much of a substance we have. And that can relate to so many different things, like how many atoms or molecules are present, how much volume a gas might take up. So mass is going to be really foundational for us in order to estimate how much of something we have. So we're going to look at three main words that all look the same here with the word mass in them. But we're going to look at atomic mass, formula mass, and molecular mass, and then what we actually use it for, which will relate to the mole. So after this little talk, we're going to continue into a new word called the mole. So jump on and let's go for it. First of all, between those three terms, we want to know what the difference is. So if you look at the words atomic mass, formula mass, and molecular mass, the name kind of tells you what it is. For atomic mass, it's going to be the mass of the atom. For the formula mass, it's going to be the mass of a formula unit, which is really just an ionic compound, okay? And then a molecular mass is the mass of a molecule, which we know is made from a covalent compound. So they're all just the masses. We call them different names because we're either talking about individual atoms, ionic compounds, or covalent compounds. So if we focus on atomic mass units, these are the units we're going to use to describe mass. So when you look on a periodic table, technically an element is not measured in grams, it's measured in atomic mass units, or what we like to call AMUs, all right? So in order to mass them out, because atoms are so small, grams would be ridiculously large. Even 1 gram of a substance could be billions and billions of atoms of that substance. So when we're talking about teeny tiny individual atoms by themselves, we need a new unit of measurement. It's kind of like if you were going to run a marathon, 26 and something miles. You wouldn't tell people how many inches you ran, right? That would be ridiculous. That would be a huge number of inches you ran in a marathon. You would say miles. So if we're dealing with teeny tiny atoms, we need a smaller unit of measurement. We call it the AMU. So what is that based off of, the AMU? Well, here's how they figured it out. They said that 1 AMU would be a carbon atom that's divided by 12. So if you had a carbon atom and you divided it into 12 individual chunks, okay? One of those 12 individual pieces or chunks would be what 1 AMU equals, all right? So that's kind of where the unit of measurement came from. And remember, it's so tiny because we're dealing with measuring the mass of atoms that are super small. So when you look on the periodic table, that mass is in AMUs, atomic mass units. Now, we use grams sometimes because we're going to learn how to easily convert those numbers on the periodic table. But for now, they're in AMUs. And notice too that on the periodic table, a lot of those masses are not whole numbers. The reason for that, remember, is they're an average of the different isotopes. So remember, something like hydrogen can be hydrogen 2, it can be hydrogen 1, and even occasionally hydrogen 3. So when you do a weighted average of all those different masses, you end up with not a perfect whole number. So again, just a little recap on the periodic table and why we do have AMUs on the periodic table. They're not often whole numbers. It's the average of all the different isotopes. So now we know AMUs are what we're going to measure these individual atoms in. Let's take a look at something as simple as atomic mass. If we look at 1 atom of lithium, if you look on the periodic table, lithium is 6.941 atomic mass units, all right? So what does that mean? That just simply means that that's the mass of 1 atom of lithium. Simple as that, 6.941 AMUs. You look on the periodic table. By the way, lithium is a super important metal to us, used in different ionic compounds and different medicines. Lithium can be helped in the medical field for people struggling with like bipolar disorder and depression. Lithium is extremely, extremely powerful though, so it does take a lot of monitoring and helping of others in order to figure out what's the right dosage of anything using lithium for people who struggle with things like bipolar disorder. But anyways, that is lithium. You just look on the periodic table and you find the mass. That's its atomic mass. It's simple as that. And of course, please know that it's in AMUs. We didn't say anything about grams yet. Well, if we look at formula mass, it's going to be the same idea. We're going to look at the periodic table for the masses, only since these are considered ionic compounds, lithium and chloride's a metal and a nonmetal, right? The fact that lithium's +1, chloride is a -1 charge, and then they come together, that's ionic. We know ionic compounds we call formula units, and that's why it's called formula mass. But in the end, to find the formula mass of lithium chloride, you add up the mass of lithium in AMUs and the mass of the periodic table of chlorine in AMUs, and you add them up, and that is your overall formula mass, 42.3937 atomic mass units. All right, and lithium chloride is actually a white salt here that's going to be found naturally on the planet, and that's how we mine and eventually do a reaction to get pure lithium. And as I stated earlier, lithium can be used in the medical field in order to help people that struggle with bipolar disorder. But formula mass is just the mass of the formula unit. No big deal, guys. Just add up the elements, and that's your mass off the periodic table. The last one, I think you see a trend here, is just going to be molecular mass. Molecular mass is just taking a molecule, 2 nonmetals or more. So this one's nitrogen dioxide, all right? And if you look, nitrogen dioxide is actually this brown toxic gas. Not nice smelling and not good for you to breathe in. But if there's 1 nitrogen, we're going to take 1 nitrogen off the periodic table. And then there's 2 oxygens, so +1 plus 2 oxygens. All AMUs off the periodic table, add them up, and this becomes our molecular mass. No big deal. We're just using the periodic table to get those masses. And all of those have been measured in atomic mass units. So now that I've been talking about atomic mass units, if we go into our lab or in everyday life and we're using scales, we're not using AMUs. We use grams or something even heavier. So the question is, what about grams? How are we going to take these AMUs that are really hard to even comprehend? If you think about one tiny carbon atom sliced into 12 pieces, and you take one of those little tiny pieces, that's just an AMU, but that is nowhere near what our regular world is, because our world is so much bigger than that. So we need to figure out a way to get to grams. In order to get to grams, when using things like mass and different compounds, we need to first figure out a new number. And that's where that word, the mole, comes in. All right, so let's take a journey into the mole and see how we can turn these AMUs that aren't very useful to us in our life into something more useful and easier to understand, like grams. And there it is, the mole. It's a cute picture of a mole, but that's not what we're talking about. Not the little animal or a birthmark. The mole is actually a word that represents a huge number. Now, since it's a new word you're not used to, sometimes people get a little confused, but don't. You are used to using words that represent numbers all the time. When you think of a dozen donuts, you know the word a dozen really means 12. It's a word that means a number. When you hear the word pair, a pair means 2. You are used to that. You know that. So now when you hear the word mole, you need to think of a number that actually is 6.02 times 10 to the 23rd power. And if you remember your scientific notation, times 10 to the 23rd means that you're going to move your decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. You're going to move it 23 places to the right. So when we write 6.02 times 10 to the 23rd, it's really this number. We just don't feel like writing out all those zeros. So we use scientific notation to note that. All right, now that is a humongous number, and honestly, I don't even know how to say that number out loud. You know, is that like quadrillions or quintillions? I'm not sure. I'm sure there is a way to say it though. However, the mole is a word that represents this gigantic number, and you might be thinking, why is this number so big, and what on earth does this have to do with anything? Well, actually, this number is going to turn our periodic table into grams. Let me explain. When we use the word a mole, it means a huge number. So if we say, I have a mole of atoms, it means I have 6.02 times 10 to the 23rd atoms. If I say I have a mole of molecules, it means I have 6.02 times 10 to the 23rd molecules. If I said I have a mole of magazines, it means I have 6.02 times 10 to the 23rd magazines. So are we getting the idea here? A mole is a word that represents a big number. It's just weird right now because it's a number that's different to you and a word you're not used to using for a number. But I didn't answer the question of why this number exists. Well, here's the answer. If you have a mole of something, it turns our periodic table's mass into grams instead of AMUs. That is super helpful to us because in our labs, in class, in a chemistry lab, at a pharmaceutical company, we're not going to use AMUs. They're too small. We need grams because that's what we can physically measure out with our hands. So here's the difference between the mass of an atom of nitrogen and the mass of a mole of nitrogen. One atom of nitrogen, individual by itself, has a mass of 14 atomic mass units. However, if you have a mole of nitrogen atoms, remember, a mole of nitrogen atoms means you have 6.02 times 10 to the 23rd atoms of nitrogen. It has the same number, 14.0067, but notice the units turned into grams. So by having a mole of something instead of just an individual atom or compound, it converts the atomic mass units on the periodic table to grams. That is super helpful to us. Why? Because when you have one individual atom, we measure in AMUs. That's not helpful to us in the lab. But when you have a mole of atoms, 6.02 times 10 to the 23rd, that we can measure in grams. And that's something we can put on a scale and actually use in our macroscopic, regular, everyday world. So the mole is important. It officially has turned our periodic table into grams instead of AMUs. And who do we have to thank for that? That number came from a man named Avogadro. And I encourage you to search Avogadro on Google. Take a look at his picture. He's an interesting fellow. But Avogadro, oh, and forgive me, I think I spelled his name wrong. I think it's Avogadro. Yes, indeed, pardon me. That's Avo, not Avogadro. My apologies. But Avogadro definitely invented this number. Pretty amazing, 6.02 times 10 to the 23rd. So thanks to Avogadro, we can get to grams now using the periodic table. But also, now that we understand a little bit more about moles, we can dive deeper into our balanced equations. In fact, these coefficients are big numbers that we've been balancing with. You didn't even realize stand for moles. So we know that this is 2 hydrogens react with oxygen molecule to give us 2 waters. But really what that means is 2 moles of hydrogen react with 1 mole of oxygen to give us 2 moles of water. And now that we have that, moles of water, we can convert things into grams. And this becomes a recipe for us that we can have in our lab. Now that we know how much mass things will be, we can figure out, all right, I need this much mass of this much mass of that in grams, and I can carry out this experiment just from this balanced equation. So things are getting exciting. This is just the beginning, but you are going to be amazed at all we can do now with our chemical equations to predict, figure out what's going to happen, how much is going to be produced, and how much are we going to accidentally waste and throw away. It's all going to relate to the chemistry field, pharmaceutical field, wasting money, being efficient, and also being able to properly predict exactly what we're going to get out. So things are starting to heat up. It's getting exciting. We covered today all the different masses measured in AMUs and how the mole can turn those AMU atomic mass units into grams so that we can use them in our everyday life. Thanks for hanging in there, science fam. Best of luck.